All right, this example deals with our scalar projections and our vector projections, as well as our vector projections or vector resolutes. And it is probably a concept that you struggled with in 2D, and you might want to go back and have a look at how it worked in 2D. The concept works exactly the same in 3 dimensions. So it's just about going back and making sure that you fully understand what we are looking for. Now remember, a scalar projection has not got any direction to it. It's just a magnitude, it's just a number, and we find that if it is the scalar projection of A on B, it's going to be my vector A multiplied by my unit vector in the direction of B. And in order to find my unit vector, I need my magnitude of B, and I'm going to go through that process. Right, so what we have is my magnitude of B is my square root of x squared plus y squared plus z squared, and in this case B is 8 squared plus negative 6 squared, and I get 5 root 5. And so then I can find my unit vector in the direction of B, which you will now remember is B over my magnitude of B, and that's going to give me 1 over 5 root 5 plus 5. Okay, so therefore my scalar projection of A on B is going to be A dotted with my unit vector in the direction of B, and that's going to be minus 6i plus 2j. Okay, that's my vector A, dotted with 8 over 5 root 5i minus 6 over 5 root 5j plus 5 over 5 root 5k. And my dot product tells me I'm going to have negative 6 times 8 over 5 root 5 plus 2 times negative 6 over 5 root 5 plus negative 1 times 5 over 5 root 5, and that value is going to be negative 13 root 5 over 5. I have already rationalized that number. All right, now in order to find my vector projection of A on B, remember what that is I'm looking for A parallel to B, okay, and that is a vector, okay, so I'm going to be multiplying my scalar projection by my unit vector B. All right, so A parallel is A dot B prime, so must be copy key, my scalar projection of A on B multiplied by my unit vector B, and so that's going to be negative 13 root 5 on 5 multiplied by 8 on 5 root 5i minus 6 on 5 root 5 j plus 1 over root 5k. And I can simplify that down to negative 104 over 25i plus 78 over 25j minus 13 over 5k. All right, now to find my perpendicular resolute or projection, that's going to be my A perpendicular. So in order to find that, all I'm going to do is say A minus my A parallel, and that's going to be my A minus A dot B multiplied by my B cup, and that gives me my A, which was negative 6i plus 2j minus k minus negative 104 over 25i plus 78 over 25j minus 13 over 5k, and I get negative 46 over 25i minus 28 over 25j plus 8 over 5k. If you can't remember that clearly, go back to the 2 dimensions and go through it again. Make sure you're understanding it.